The rule of reductio ad absurdum, rule RAA, captures the idea of a proof by contradiction. So the structure of the rule is here. You begin by assuming the negation of phi, you reach a contradiction, and therefore by applying the rule of the reductio ad absurdum, you cancel your assumption and you can assert phi. So what the rule allows us to do is to remove the negation from your assumption. The idea behind this form of reasoning is that you can establish a positive claim phi by showing that the negation of phi leads to a contradiction. And so once you have shown that the negation of phi leads to a contradiction, you can simply remove the negation of phi and assert phi outright. That's the basic idea underlying proof by contradiction, also called an indirect proof, because you are not establishing phi directly, but you are indirectly assuming the negation of phi, showing that this leads to a contradiction, and concluding therefore that phi must be true. The rule of reductio ad absurdum, RAA, or proof by contradiction, allows us to construct a derivation for the claim that says that two negation makes an assertion. This is the claim that not phi implies phi. The derivation goes as follows. First, we assume not phi. That's the first assumption. We label it 1 and we put it between square brackets. We also assume a second assumption, namely not phi. So this is a simple negation of phi. We put it between square brackets and we again label it 2. From these two assumptions, it follows that the contradiction is the case. This is the symbol with the two lines, one perpendicular to the other. Recall that we can write the contradiction as an application of the rule of implication elimination because of our notational convention. So when you see a negated formula, you should think of this negated formula as the formula implying the contradiction. That is why we can write the contradiction in the next line as a simple application of implication elimination. I invite you to write this down and see this for yourself. The next step is an application of our rule reductio ad absurdum, and this allows us to derive the formula phi. So note that we labeled not phi number 2, and we are applying a reductio ad absurdum to this assumption number 2. That's why we put a superscript 2 next to the label reductio ad absurdum. This allows us to remove the negation of not phi and write simply phi. Finally, we can use an application of the rule of implication introduction, which we apply to our assumption number 1. That's why we write that superscript 1 next to the name of the rule. And in the next line, next and final line of our derivation, we can write not phi implies phi. This is the formula we want to derive, and this formula says that two negations make an affirmation. Note that this derivation rests crucially on the application of the rule reductio ad absurdum. I challenge you, try to derive this formula without using the rule reductio ad absurdum. You will not be able to do it. Now you might ask yourself, who would deny that two negations make an affirmation? Well, there are some mathematicians and logicians who deny this assertion. These are known as intuitionistic logicians, intuitionistic mathematicians, and you see in this picture Brouwer, a Dutch logician who is perhaps the most famous intuitionistic logician, who denies the principle that from two negation we get an affirmation. So those who deny the reductio ad absurdum rule are called intuitionistic logician, and they believe that in mathematics there shouldn't be any indirect proof, but only constructive or direct proofs.